Hello there, welcome to this Shieldier guide where I will be explaining the file upload vulnerability within the Damn Vulnerable web app on low security from the red team perspective. Today we're going to upload a reverse shell, so a bit more of a structured explanation as to what the reverse shell is, how we upload it, how we can exploit some of these vulnerabilities in the lack of file upload control. In the blue team perspective, I'll demonstrate how we can detect the reverse shell and then a side channel on how we can use the firewall logs to detect anomalous network activity. Finally, in the purple team, we will be able to automate all of this. And then just a brief aside, within the medium security post, I will describe how we can use a framework like Villain to be able to tie together all of these reverse shells in a systematic way so that when you drop your shell, you'll then be able to get it within the Villain framework. Prerequisites, of course, you're going to need the red team or the blue team setup if you want to follow along at home with all of the aspects that are going to be discussed throughout this guide. Moving on to the red team perspective, what this vulnerability entails is essentially a lack of controls from the server to validate what type of files get uploaded and how they get executed in regards to the MIME type. We have the sequence diagram here, the normal preamble to login, setting the security to low, all of that. Then we'll send a post request with the contents of the file to be uploaded onto the server. Then we will check to see if we've successfully uploaded that file. And then if we have, it'll mention successfully uploaded. If not, it won't mention anything. There are a few ways filtering can happen. They can either happen server side or client side. Client side filtering is trivial to bypass. Server side filtering as well. Within PHP, there are some exploits in how it deals with null characters that can be exploited if they're just using a basic filter. We will discuss more on this within the medium security blog post. First, we want to access the Damn Vulnerable web app. So within the Tartarus lab, you can open the Kali instance and then log in. Login. We can now set the security to low, which it is already low. Great. File upload is the vulnerability we will be testing, and now it says choose a file to upload. In this case, it could be any file. To be honest, it says an image, but it can really be anything. So in the blog post, I just found a random cute cat picture and then use that to upload. You will note, however, there is a max file size of 100 kilobytes. If the file is larger than that, it just won't get uploaded. This setting is set server side. I tried to do some tampering, like upload thousands of files to see if they would DOS the server. There wasn't really any interesting avenues there to explore. But that aside, there is a maximum file size. If you're trying to upload an image and it doesn't upload correctly, make sure it is smaller than that. Once you upload the image, you will see that it'll print a message successfully uploaded. Then if I move myself over there, in the request headers, this is the content that gets uploaded. So this is a content type or MIME type of image/JPEG, and then that is the actual content of the file in the sort of raw bytecode. We don't need to worry about it, but that's just to say that's how the file gets uploaded to the server. We can then access the file, which is a key component of being able to successfully execute these vulnerabilities, because even though you may be able to upload it, if there is no way to trigger it, then there is no way to activate your reverse shell to come back to your machine. So those are the two key principles that we need to follow, is that we can upload. In this case, it's an image, but it could also be a reverse shell from rev shells, as I will explain. And then similarly, we can retrieve it to activate it. if the MIME types are understood incorrectly, or correctly in this case. You'll use rev shells and then generate a reverse shell like this, the PHP pentest monkey, with your source IP address. If you're in the Tartarus lab, it's easy enough. And then the source port, like the Tartarus lab, you can only access on port 80 and 443. Then you'll paste that into a file with Control-Shift-V. I already have a file downloaded. So ls rev, I will just quickly create the file now. By rev shell.php input, and then we can go to revshells.com and then generate it quickly. Cool, let's remove my settings. We can go to PHP pentest monkey, copy that. We're already in insert mode, Control-Shift-V to paste, escape, and then :X to paste the file. Now we can upload the reverse shell. It will be, you'll browse to wherever you've saved the rev shell on your attacking Kali box, and then select that file for upload. So here I will browse, and then right there, revshell.php, and then upload. Successfully uploaded. So it's not doing any content checking to make sure that it is the correct file type. It is just uploading any file. It is just accepting any file. Now we must bless Netcap with the capability to bind to privileged ports if you haven't already. I have, so I will just run netcat and then listen on port 443, which is normally a privileged port within the Linux system. Normally only root would be allowed to do this. Now we are listening for that reverse shell connection, and then we will execute it on the server to activate this reverse shell and then connect back to our attack box. There are two ways you can do this. Either go up two directories, so there, and then up that directory, and then from the root damn vulnerable web app, then you'll go to hackable uploads reverse shell, which is the way we will do it. Or you can include the double dots and then relatively move your path, but we don't need to do that. We can just paste it like that, and then it's going to hang. It's going, oh no, what's gone wrong? But it hanging is purposeful because we have activated the reverse shell. And there we go. We have successfully caught our shell and can do what we want on the server now. I'm not going to cover in detail what we can do. That will come in later posts. But we can do something similar with curl. You don't actually need a browser to do all of this. You could do everything we've done here just in curl. When you Control-C to cancel and drop your reverse shell, you'll see an error page here. Not to worry, you can go to the root directory and then everything will be fine. Moving on to doing this via curl, I'm going to create a little HTML file that looks like this, just by way of example to illustrate how this might work in an engagement. By hello.html, and then again insert mode, paste, and then exit. We can now get a valid login session using the subshell method. Now we have a valid login, and we can use that with this. Here, if you look in the Tartarus lab provisioning scripts, this should look familiar with how we are using curl to upload we don't do any file uploads, but this is how we format all of the curl requests in the Tartarus lab provisioning scripts. You can see we're specifying the post method where our target is. We're specifying some headers. So host is Tartarus except any condition closed. We can do condition keep alive as well. And then finally the cookie header field, so that we can present our PHP session ID and then set the security to low. We then set in a field the max file size, and then uploaded equals, which is how, if you do it via the browser, you'll see that that's the field that they use. And then you can use the @ symbol. So ours isn't called file.html is called hello.html, so I will edit that. And then you input the type, text for the MIME type, text, HTML, or content type, and then another field, upload equals upload. So here we can edit this to be hello.html. We can now look, hackable uploads hello.html successfully uploaded. We can now review that file if we want to, just to make sure everything has worked. Again, Control-Shift-C from the root directory, we get rid of that, and then hello world. A simple HTML file is being served that we've uploaded all through curl, no interaction within the GUI. Great. Moving on to then finally the blue team, how they will be able to detect this activity. So I'll see you in a little bit. And now, how do we detect this reverse shell on the Linux system? There are a few different methods we could employ. Some, however, are clearly out, like described here. Using just the file name or something like that is not viable, because it's just going to be false positives. So we're not going to do that. Instead, like we have looked at previously, we will investigate it via the EQL correlational engine, so that we can see any user process that has the username www.data and the process command line is SHI and then anything. So we can log into the seam, have a look at this activity that has been done throughout the red team perspective. Within timelines, we want to, again, this may be different for your specific seam. If it has this capability, then great. If not, well, Elastic has it. So the EQL, we're going to look for where process, wdata, and command line like that. I'm also going to change the time window to the last hour to only look for recent reverse shells, so that cleans up this a little bit. So process executed. Let's see here, I can add what process command line, the little plus adds it as a column, and then this will show me, okay, let us then have a look at this event. So Apache 2 sh uname www.data. So this looks like it has been this was the reverse shell. We can see here that is the default commands that the PHP pentest monkey rev shell would run. Then we can see with this shell interactive, it has then run ls to list the directories. Excellent. So we have successfully, just through the EQL correlation, found that activity. Sorry, just move back there. There we go. Found the activity. Now we can create that into a Sigma rule if we wanted to. Here it's looking for bash or sh, and then the specific pipe or the specific greater than or less than symbols for the redirection that would normally happen when you spawn a shell like that. And then we're doing a regex search for them, which will raise an alert. If we look in the alerts tab for the last hour, we should see that activity successfully picked up. So over here we can see, boom, process creation web reverse shell. Great. Now, how could we, a bit of a side channel, how could we detect this activity in a more agnostic way? We could, as it says here, look for Metasploit default ports. Pretty boring if you ask me. Instead, with a correlation, so like the EQL, we can look for anomalous network activity that a web server wouldn't normally do this type of activity. The web server gets a connection in on, let's say, port 80 or port 443 and then replies with the response to an arbitrary port. However, here we're going to look for this source IP is the hacker's zone in the OpenSense firewall. This destination IP is our target web server addresses. You'd have to change this, of course, to match your environment, but here this is how it would make sense. So if we think of this as maybe non-RFC 1918, so it's an outside address connecting to one of our web servers, again, could also be an non-RFC 1918 address space, so a AWS or Azure or GCP, it doesn't really matter. We're looking for the destination port 80 or 443 that initiates this connection, and then in that same instant we want to look for a connection that happens outbound. Why this does not match traditional, like just grabbing the web page activity, again, that happens in a slightly different manner than what this is looking for. So we won't then catch just normal web traffic activity. Instead, we will only catch what would be reverse shell activity. So we can copy that and then go to our timeline under correlation rules. And then we can see here, we've successfully found what we suspect to be a reverse shell attempt. So at that time, that's the activity that happens. Just to verify that it's not going to catch normal web traffic activity. Well, you can see there, but here as well, the vulnerable web app will go, this is port 80. So, but due to the nature of the connection, it's not going to show up in our correlation rule. It'll only catch a reverse shell activity. Make sense? There you go. So you can see here within the last hour, there's this source IP being the Kali instance to the destination IP being the web server. And then in that same instance, a new network connection happens from the web server to the Kali instance, which would indicate a reverse shell or some activity that a web server would not normally undertake. This is taking advantage of how the stateful firewall will log these connections. It would normally log this as a session, if you will, because these are two separate sessions that happen at the same time, as opposed to a normal network connection. Then here, another side channel, the roof is on firewall, just explaining why it does not catch that activity in the search that we're running, because everything is logged, again, statefully within OpenSense. So here we can see this sequence diagram as I've explained before in the first recon post, how the SYN-ACK TCP three-way handshake works. You'll set one with the header flag SYN, then the server will respond if the port is open with SYN-ACK, and then you acknowledge that, and then you can initiate your connection within the application layer here. You see it sends a GET request, for example, to log in the host, all of that sort of stuff that we looked at the headers. Then the server will respond with OK, content type, text, blah, blah, blah. Don't need to worry about that. And then at the end of the connection, you can tear that down with the four-way teardown, where you ask the server to fin, then the server will acknowledge that, and then it'll ask you if you really want to finalize the connection, and then you acknowledge that, and then your session, your TCP session has been terminated. Looking at that in more detail within Wireshark, this is what it would look like. It's a bit daunting, don't worry. We have source and destination here. So source is our file, is our Kali instance going to the web server with the protocol TCP. Then there's some length information. So from this arbitrary port to port 80, and then etc. etc. The server will then respond. So its source port will be port 80 with a SYN-ACK to our arbitrary port that we opened the connection with. Then we acknowledge from our arbitrary port to port 80, yes, we acknowledge we want to proceed with the connection. Then with the HTTP protocol, we send a GET request, It will then acknowledge that, respond with the content, and then we can, if you set the session close, it will close the connection immediately. Like we have here, we set session closed in this curl request, connection close. It'll close it immediately, so it won't be keep alive and then slowly keep that session alive. We don't need to do that for these examples. So it'll do the 4-way teardown at the end. How does it look in the logs? It'll look something like this. You can do source IP address that, destination IP address that in the firewall logs. So you could add a log source to be the pfSense firewall or the OpenSense firewall. You can see here, destination port 80, it's only logging the SYN connections. It's not logging anything else in that exchange of information. Then how, from the attacker's perspective, this is what that connection would look like in regards to a reverse shell. So this is what it would look like. And then in regards to what does it look like in the logs, it's very similar. It's just logging the SYN from source port 80 to, so from destination port 80 and then to with the attacker as the source, and then with this web server as the source to port 443, which may look kind of innocuous because it's port 443, it's supposed to go out there. But in these instances, they happen at exactly the same time. So that would indicate that it's a reverse shell. There are some obfuscations that can be done, of course, but as a brief way to potentially try and identify this activity, this is one method that you could use. And moving on to, I don't have a seam. It's just not what I've got. So we can use some of the, as explained before, the audit delogging to be able to identify this activity. So that would be from the terminal you ran vagrant up from. You then will run vagrant SSH damn vulnerable web app. This will then use the SSH identity file to log in. We can do an AU search for the specific key value that we're looking for in the audit delogs. These look quite promising, LS. I'm going to look for a little bit of a longer one. So this one here looks like it could be interesting. So Control-Shift-C, Cyber Chef from Hex is great because that's what we need. And then we can paste that in here and remove that. Boom, that's our reverse shell. SHC uname is the command that will get run when the PHP reverse shell is ran. And that's it for the blue team perspective, how you might investigate some of this activity, how you might identify it, a Sigma rule, an EQL rule to be able to abstracting up and actually looking at the network behavior that would happen within that session. Then how do we automate this? That'll be in the purple team part of this video in a second. And now finally, how do we automate some of this testing? Nuclei is a great option. As explained in previous posts, it is a very powerful automation engine to emulate a browser. This Nuclei template that I've created will be able to upload different file extensions to the target. So here under the variable section, there is the standard username and password so that I can log in. Again, this can be in HashiCorp Vault, it doesn't really matter, but for sake of arguments, this is a lab, don't worry about it. The file extensions, you can provide it an array of what would be available PHP file extensions, some TXT, some zipped files, or some compressed files, and some other file types. We then will run through, log into the application, run a for loop over all of the file extensions, that array, and then upload it with the HTTP3. So this again logs in, sets the security to low. This is what our file upload looks like. So to a browser, this is how files get uploaded. We are setting all of the variables, and then here, form data, name upload, file name, we are randomizing the file name to a 10-digit number, and then the specific file extension for that attempt. So it'll start with PHAR, and then be PHP, PHP3, PHP4, all of those, and then all of those will have different file names when it's uploaded to the server. We then do a matcher for a word within the response to be successfully uploaded. I know if this was actually going to be in the GitHub, it would be in the templates GitHub, it would be like a dual matcher. You'd look for the status code and then you'd look for the words as well, but we're not going to worry about that. Then the extractor, and we extract the specific name so that it can be printed to the screen. What that looks like when we run it, we can quickly run it on our Kali instance. We can minimize that, clear the screen there. Then this will just go through, log in, and then upload those different file types. So you can see here a random with all of the different file extensions, and those all successfully uploaded. So that can give you, if you wanted to quickly test which file extensions, if it's doing any file extension filtering, which file extensions am I actually allowed to upload. Moving on to the Omega CLI, there is a test for the reverse shell. So this is an executors template. Starts a netcat listener and then does the reverse shell with the file upload method, as I believe explained in one of the previous posts. So we can, if you have Omega downloaded, cd into it, and then just run the test. It'll then do everything for you. You can then, again with the debug flag, look at how you could run these things to debug on your guest. You can use a Docker run and then the specific Docker container, and then passing in some arguments. And then similarly with the nuclei container, that's how you would run it. Here you can see that the shell has successfully been caught by that. So that's the netcat container has successfully caught the reverse shell. There are some limitations in regards to how you could and where you could run these. Of course, it's not really feasible to do this in a CI/CD pipeline, because how do you connect back? But within this lab, it works perfectly fine. And there you can see the alerts from the Elastic Seam successfully catching the activity. And that is all I wanted to talk to you about today. Thank you so much for joining me, and I will see you in the next one.